Hello and welcome back. This is Greg French. Today we're going to be covering Chapter 5, Part 2 in our A+ computer repair series, CPUs and chipsets. The Intel processors. Early model numbers were 8088, 8086, the 286, the 386, and the 486. It's interesting, IBM chose to use the 8088 as their first chip to introduce to the public. It was only an 8-bit processor, even though the 86 was available at the time. The 86 was a 16-bit processor, but shortly after IBM came out with the computer, they did go ahead and come up with a new one, a new update, using the 8086. New 3-digit processor numbers, the Pentium series, the 500 to 800, the Celeron, and the 300 series, and the Pentium M processor, 700 series. Overview of the Pentium family of processors. 2 arithmetic logic units, ALUs, are used for multiprocessing. Remember that was kind of the standard since 1993 to incorporate 2 ALUs. 64-bit external path size and 2 32-bit internal paths. 8 types of Pentium processors. Example, the Pentium 4, Celeron, and Xeon are offshoots of the Pentium family. The Intel processors continued. The older Pentiums no longer sold by Intel. The classic Pentium, the Pentium MMX, the Pentium Pro, the 2, and the 3. The 2 was retired after the Celeron came out. The Celeron was actually a cheaper chip, but the story again is the engineers did such a great job on the cache performance that it was able to surpass the performance of the Pentium 2. Uses a 486 pin socket or a 775 LAN socket. Uses level 2 cache within the processor housing. So now they have both level 1 and level 2 that they're using. Pentium 4 runs it up to 3.8 gigahertz. Later versions use the hyperthreading, that newer technology of hyperthreading. The Pentiums are sometimes sold boxed with the cooler assembly. A lot of times you just see the chip right here just sold by itself, but then also a lot of times Intel will actually put it in this larger box along with their standard heatsink and fan. It's nice to be able to buy those together. Otherwise, after you buy the chip, you have to buy the heatsink separately. Intel processors continued. Some mobile Pentium processors, the Pentium M, the mobile Pentium 4, and the Celeron, some of their notebook type processors. The Xeon processors use the hyperthreading technology and dual core processing, designed for servers and high-end workstations. The Titaniums utilize the EPIC, which is a newer instruction set than the CISC, which was the complex. External data path is 128 bits. The L1 cache on the processor die, L2 and L3 are now on board. The Intel Titanium processors, here you can see we've got the Titanium 1 or Titanium and Titanium 2, the different speeds of the two, the type of cache. You can see that Intel is very, very stingy on the amount of cache. They have increased that considerably now. And the different bus speeds. This is fairly older technology. AMD processors, manufactured by Advanced Micro Devices Incorporated, geared to 64-bit desktop. Now, AMD was kind of the pioneer for the 64-bit, and their mobile processors, they took away the performance of Intel there for quite a long time and started taking a lot of market share away from Intel. Older AMD processors use motherboards not compatible with Intel processors. Earlier processors used a 321-pin socket, so it was a non-standard socket. Current AMD processors for desktops, the Athlon, the 64, dual-core, Athlon 64 FX, very high-performing processors. For servers, the Athlon MP and the Optron. For notebooks, they came up with a Turon, which was a new type of processor, a little lower price, but performing very well. And the mobile Athlon 64. Here's a chart concerning the AMD processors, the Athlon Model 4. VIA and Citrix processors use same sockets as earlier Pentium processors. Their target was the personal electronics and embedded devices. 3 processors that they came up with, C3, C7 for electronic devices, and the C7M designed for the ultra-small notebooks. Processor packages. The processor packages provides for the processor housing and how it integrates into the motherboard. Flat and thin processor packages, they lay flat in a socket on the motherboard. Connectors can be pins or LANs, which is the newer type. Intel examples, the plastic pin grid array. AMD examples was the ceramic pin grid array. Cartridge processor packages can be installed on a slot or lay flat in a socket. Intel example was the SECC, which was the single edge contact cartridge. Stands in a slot 1 on the motherboard. Here's the Intel Celeron processor. Is housed in a pin grid array type form factor, which has pins on the underside that insert into a socket, socket 370. Here's another example of the slot, Pentium 2 with a heatsink and a fan attached to it. It goes in the slot 1 on the motherboard. This was a big development, latest development at its time. They thought this was going to be the new way that they were going to build processors and put them on the motherboard, but it only lasted about a year or two. Then they went back to the pin grid array. Processor sockets and slots used to connect the processor from the motherboard. Motherboard type must match the processor package. Types of sockets. Sockets are built around pin grid array or the LAN grid array. Variations. Several examples. Types of slots. Slot 1, slot A, slot 2. Newer processor packages uses sockets, not the slots. We've moved away from the slots. Sockets looks like slot 1 to the processor requiring the socket. Here's a little plastic cover used to cover your LAN grid arrays, or you don't have a CPU installed. Here we have the riser card on the motherboard. It can be used to install a Celeron processor in the motherboard with slot 1. In review, Intel processors. We've talked a lot about the Intel processors. They have taken away the market share back from AMD. We have a lot of cache now on board the Intel processors, which really helped to improve the performance quite a bit. AMD processors, it's very good. They're still around, pushing Intel to make faster and faster chips. So we need that competition. The slot, the pin grid array, and the LAN grid array. LAN grid array is now what is used. No longer pins, but it's actually pins that are kind of like on their side that lean against or have kind of a spring tension that is used against the sockets. Chipsets, very important. Chipsets are what really helps to make sure we have a high-performing computer. We need fast memory. We need a chipset that will support fast memory. We also have to have a fast bus for our video card. The chipsets support that. Activities. I want you to research the PGA and the LGA and get ready for a discussion as to what's going on with those two technologies, where we headed for the future, why one differs so much from the other. Lab 5.2, 5.3, the PGA and LGA, the types of pins and LAN grids for the CPUs. I want you to go ahead and do those labs and then turn in the review questions at the end. That's it for this one. Thank you very much for your time. Bye.